Alright, so in this problem I have x to the power of 3 is equal to x to the power of 5. So I want to find the value of x here. So for my solution, first start with x to the power of 3 is equal to x to the power of 5. Now, I'm going to subtract x to the power of 5 on both sides. So now these two are going to cancel out. Now I'll be left with x to the power of 3 minus x to the power of 5 is equal to 0. Now x to the power of 5 I can rewrite as x to the power of 3 plus 2. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, x to the power of 3 plus 2, that's going to equal x to the power of 3 times x to the power of 2. This is equal to 0. So now, from here, notice how both of these terms have x to the power of 3 in them. So if I factor out x to the power of 3, I get x to the power of 3 times 1 minus x squared. And this is equal to 0. So now from here, this gives me two equations. I have x to the power of 3 is equal to 0, and I have 1 minus x squared is equal to 0. So for x to the power of 3 equals 0, I'm going to take the cube root on both sides. So the cube root of x to the power of 3, that's simply x, and the cube root of 0 is simply 0. So x equals 0 is one solution to this problem. Now, for 1 minus x squared equals 0, I'm going to add x squared on both sides. So then these two cancel out, and now I have 1 is equal to x squared. So now I'm going to take the square root on both sides. So I have the square root of 1 is equal to square root of x squared. So the square root of the square root of x squared, that's simply equal to x, and the square root of 1 is equal to the positive or negative 1. So these are two more solutions to this problem. So now to check, I have x to the power of 3 is equal to x to the power of 5. So first off, let's check 0. If x equals 0, I have 0 to the power of 3 is equal to 0 to the power of 5. 0 to the power of 3 is 0, 0 to the power of 5 is 0, so this is right. So now if x equals 1, I have 1 to the power of 3 is equal to 1 to the power of 5. 1 to the power of 3 is 1, 1 to the power of 5 is 1, so this is right. And finally, if it's negative 1, I have negative 1 to the power of 3 is equal to negative 1 to the power of 5. Negative 1 to the power of 3 is negative 1, negative 1 to the power of 5 is negative 1, so this is right as well. So all three of my solutions are right. Alright, so in this problem, I have 5x to the power of 5 minus 5x is equal to 0. So, to solve this problem, I'm going to first start by factoring out 5 from 5x to the power of 5 minus 5x. So now I have 5 times x to the power of 5 minus x is equal to 0. Now, I can go ahead and divide both sides by 5. So then these two cancel out. And now I'll be left with x to the power of 5 minus x is equal to 0 divided by 5 is 0. Now, x to the power of 5 minus x, I can simply factor out x from here. So now if I factor out x, I get x times, x to the power of 5 divided by x is x to the power of 4. And negative x divided by x is negative 1. So this is equal to 0. And now this is going to give me two equations. I have x is equal to 0, and I have x to the power of 4 minus 1 is equal to 0. So x equals 0, this is already a solution. So now I'm going to go ahead and solve x to the power of 4 minus 1 equals 0. Well, x to the power of 4, that's the same thing as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, So we go x to the power of 2 to the power of 2 minus 1 is the same thing as 1 squared. So this is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, if x squared to the power of 2 minus 1 squared, a is equal to x squared and b is equal to 1. So I have x squared plus 1 times x squared minus 1 is equal to 0. So this gives me two equations. I have x squared plus 1 equals 0, and I have x squared minus 1 equals 0. So for x squared minus 1 equals 0, I can simply add 1 on both sides, and I'll be left with x squared is equal to 1. Now I'm going to take the square root on both sides. Square root of x squared is simply x, so I have x is equal to positive or negative 1, because the square root of 1 is positive or negative 1. So these are two solutions. And now x squared plus 1 equals 0. I'm going to start by subtracting 1 on both sides. So I have x squared is equal to negative 1. Now I'm going to take the square root on both sides. Square root of x squared is x, and the square root of negative 1, this is actually equal to the imaginary number I. So I have x equal to positive or negative I. So these are two more solutions to this problem. So my solutions are x equals 1, x equals negative 1, x equals 0, x equals I, and x equals negative I, for negative I. So these are my 5 solutions to this problem. Alright, so in this problem I have 5 to the power of x is equal to 7. So the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7. Now if I have something in the form log a to the power of b, I can simply move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x. So I can move x to the front. So now I'm going to have x times log 5 is equal to log 7. Now, to simplify this, the value of log 5, this is equal to approximately 0.8451. Log 5, this is actually equal to 0.6990. And log 7, this is equal to 0.8451. So these are my two values for log 5 and log 7. Alright, so now what I'm going to do is I'm going to first start by dividing both sides by log 5. So then these two cancel out. And now I'm going to be left with x is equal to log 7 over log 5. Now, I know that log 7, this is equal to 0.8451. And log 5, this is equal to 0.6990. So now I have 0.8451 over 0.6990, which is equal to 1.2090. So this is my answer. So now to check, first start with 5 to the power of x equals 7. I know that x equals 1.2090, so I have 5 to the power of 1.2090 is equal to 7. Now, 5 to the power of 1.2090, that's equal to approximately 6.99, so I have 6.99 equals 7. And 6.99 rounds up to 7, so I have 7 equals 7. And because this is right, my solution is right. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this and rewriting 25 as 24 plus 1 is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2. And I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12 because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4,000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4,096 squared is really hard to calculate by itself. So if we change it to 4,000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4,000 and b is 96. So this turns into 4,000 squared plus 2 times 4,000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now 4,000 squared is equal to 16 million. 2 times 4,000 is 8,000, and 8,000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem.